I gave you a little piece of cardstock because I thought this is probably about all that you care about. However, I will show you where you can find the entire syllabus, which we will go over right now. So on our Moodle page, which is pretty scant at the moment, you will find under Important Documents and Information, this is all that's there. So the aforementioned class videos are there. So if you need to relive the magic of being in class, or if you've missed because you're on a, I don't know, medical school trip, or like these, sometimes people go and they go check out medical schools or professional schools. Anyway, you can see what you missed on the class videos page, and when you click on that, you will find that it is organized. Eventually, you will have right now this is this is today. It's actually live, but don't let that worry you. But anyway, so you'll be able to find, I will eventually have nice images like this, and then underneath you'll be able to see what we discussed. So if you're like, I know I need to review chi-squared, test for independence, well, that wouldn't be this class, would it? But integration by parts, for example, just go look for Calculus II, integration by parts, and you'll find the class where we did integration by parts. But that will be in the future. You'll be able to find that. For now, though, the thing that we want to discuss is the syllabus. So I gave you this little piece of cardstock because I thought it could serve as a bookmark in your textbook. There it is, so that you know where you are. And then you have access to the most important information. However, the entire syllabus is available online. And so here it is, as you saw. So let's just go through this. It's going to be boring. I apologize, but that's the way it is, especially for those who are here for my first hour. I'll try to be quicker, though. So first things first, this is the wrong one. Sorry, there it is. That's better. I was looking at it thinking that's not right. Okay, yeah. Okay, so you know me. I'm John Noonan. I'm a professor of mathematics here at MVNU. I've been here for this is my 28th year, so coming up on, my first trip to Mount Vernon was in May of 1997 for my interview, and then the rest is history. So anyway, you've got that. You can find my office in Faculty Hall. If you don't know where Faculty Hall is, as you're walking from chapel to the cafeteria, you walk past the Eternal Flame. As you're walking past, you will see a building on your right. That is Faculty Regents Hall. Faculty Hall is the portion of the building closer to the chapel. Go in the first doors, you'll find my office immediately to the right. So you can make appointments with me. You can certainly just pop in. I have an espresso maker as well as hot pot and other devices to make warm drinks for you if you need them early in the morning. I'm happy to do that. Just come by. You can also make appointments. So I'm usually here by 6:30 or so in the morning because I'm anxious about being ready for classes, so I like to be here early. So if you come in early, you can do that. You can make appointments with me as early as 6 a.m. And I've had students make appointments for 6 a.m. And I will be here at 6 a.m. if you want me to be here. So that's how you would make an appointment. However, you can also just pop in. Don't feel like you have to make an appointment. You can just pop in. If you have the full version of, if you go online, you can click that link and make an appointment with me. But scanning this with your phone works as well. You can contact me via these different things, but email is probably the best. But if you do text me, do let me know who you are. So there's my cell number. I don't answer this unless it's my wife. So if you call, I'm not going to answer. You can leave voicemail, but if you text, let me know who you are, and then I will at least have a clue as to what's going on. So you have a course description. I think that's on your little thing. Let me see. No, I skipped that. So you can find it in the catalog. This is just a course description for the catalog. We're going to be doing the first half before spring break. We deal with limits. Oh, wait. I guess that's right. It just seems weird. Why is that the description? I guess we need to change our description. Anyway, before spring break, we will be dealing with differentiation and integration methods. applications. Yeah, that's before spring break. And then afterwards, it's pretty much power series every day, all day, to the point where we'll be sick of power series and Taylor series and Maclaurin series and all these other series. So this, I've been told by students who have graduated that this is the worst or the hardest of all the calculi. And so I say that not to scare you, but just to, just be aware. This is a little bit of a slog, especially after spring break with all of the power series. We will take our time though. It'll be okay. And it is a fascinating subject. So I don't want you to be discouraged that it's boring. It's amazing, but it's hard. So just be forewarned. So we have that. The textbook is any version of James Stewart's 8th edition of Early Transcendentals is going to be fine. So you can have this big, thick one if you want to impress people with, your weightlifting, or you can have is that the thin one? Yeah, it's the thinner one. That's the single variable version. So yeah, you can use this. It's about, I don't know if it's 3 kilograms exactly. It might be just 2.5, but it's pretty hefty. So you can use this for weight training, or you can just impress people with how thick it is. But yeah, any version, there are a bunch. I emailed you because I should have done it earlier in the fall, but I didn't. But hopefully you're able to find something that is relatively cheap. For example, Hayden, how much did you pay for that thing?
I think it was somewhere around 80, 90.
Really? I'm sorry. I was hoping that it could be like in the less than that, but okay. So he must have waited. Hopefully you can, if you haven't got one yet, hopefully you can find something that is cheaper than that. And if you're on the fence as to whether you want the big fat one or not, you can, you get the fat one if you're going to take multivariable calculus in the fall, because the multivariable stuff is at the end. If you're not going to take multivariable, don't bother getting the fat one. Okay, that's that. Next, so there's the textbook. Yeah, if you have concerns about the textbook, come see me. There's so many different versions. There's a loose leaf version, which one of my daughters had when she took this class years ago. And she actually kind of liked it because she would take just the portion that she needed for the week or 2 weeks, and she would stick it in her little, so she had this little tiny binder she would carry around, a little thin binder. So there are different versions. So you might look into the loose leaf one if you haven't picked one yet. Okay, so there's that. Let's see. The rest of the stuff on this page of the online syllabus is stuff that you might not care about that much, but I'm required to put on here. Things like course objectives, course rationale. Basically, you should have passed Calc 1 to be in this class. Okay, so course policies. Here's where we need to get serious. So on your little cardstock, I have some pretty brief versions of this. But basically, class attendance, don't skip. And if you do, communicate. But the larger story is there's a policy that's university-wide. I'm required to take attendance, apparently by federal law. It's because of how we're classified in terms of educational institutions. But that's neither here nor there. But our policy is that if you miss 3 full weeks of classes, so that means for us, it would be 3 times 4, 12. If you skip 12 classes, you are or more than 12, I should say, so 13 classes, then you are administratively withdrawn, which, to be honest, when that happens, I'm usually relieved because it's like, I don't have to deal with that person again. If you've skipped that many classes, then you are definitely not really committed to learning the material. So it usually comes as a relief to me, but it might be a shock to you. So don't skip. Don't skip. And to not become a thorn in my flesh, you can communicate. That's the other part of this. That if you communicate, talk to me, let me know how things are going. Then I usually am like compassionate. I'm like, oh, I don't want you to, I'll try to keep you from having to be administratively withdrawn. So don't skip, and if you do communicate. Late work. Let's see, where are we on? Yeah, late work. So yeah, you'll get a penalty if you hand things in late. So there's that. Quizzes never made up, mainly because I have a quiz every single day, and it becomes a nightmare to try to figure out who needs to retake what quiz. So my policy is as follows. If you miss because of an excused absence, it just doesn't count for or against you. And if you've had me before, you know how it works. It just goes into the grade book as a blank or a dash or something like that. If you skip because you decided to go to snow trails that last time before all the snow melts, then I give you a 0 for the quiz, which isn't that big of a deal, but you know, they do rack up if you have too many zeros. So don't skip, and then you don't have to worry about that. So quizzes, I never make up quizzes, and yet people always ask me, can I make up that quiz? I'm like, no. Then tests, if you're going to miss a test, usually you'll know ahead of time, so do communicate about that with me. We will deal with it. Okay, so there's that classroom decorum. Laptops, cell phones, tablets are prohibited. Sorry, guys. So you can put away that Clash Royale or that Brawl Stars or whatever it is that you're playing. Yes?
What if I use my tablet to take notes?
Yes, that's here on the second part of this. So Michael's got a great point. Thank you, Michael, for bringing this up, because you can be my example. So I know that some of you use your tablets to take notes. For example, I might be like here, wow, this is great, with a smiley face, and then I have a reminder to myself that I need to set up a remind site thing so that I can let you know if I'm going to miss, because morning, I don't care about my afternoon classes, to be honest, but morning classes, I care because I know that you might be in the position to be able to sleep in if you, I would hope that an afternoon class, if I wasn't here, it would just mean that you go to lunch early or something, not that you were still asleep at that point. But yes, so I know that some of you do use tablets, and so just talk to me afterwards. I don't have it with me. I should have brought it, but I'll bring on Monday a few of these. They're very short, this size, just a little agreement, and basically it just is an agreement that says that, you know, I know you're using your tablet, and you use it for good and not for evil. So anyway, we'll, I guess don't bother talking to me. You've already talked to me. I will bring that on Monday for you and for anyone else. If you want to be like Michael and have your tablet, then talk to me. So yeah, it's right there. I know it's not on this cardstock, but it's here, and I can do that. So thank you for reminding me of this. Inclement weather. If we miss class for snow days, I'll be on campus anyway. It's just years ago, and this is from, I remember the very first snow day that I had here. It was like 20 years ago, and I didn't know it was a snow day, so I biked to campus, and on the way to campus, I actually got off my bike to help push a truck out of a ditch. And then I kept going, got to campus, and then like no one's around, and I realized, oh, I guess we have. So since then, I've kind of made it a tradition. I come to campus anyway. It's kind of a flex at this point, just like, you know, I can get here on my bike. Why can't you? But I say that to say that at times in the past when we've had snow days, I've had students come to my office for help during the, you know, the closure, you know, because you're here anyway, and I've got my espresso machine. I can make you some warm drinks if you need. To some encouragement. So there is inclement weather policy, though, that if we do have to cancel class, I will have something asynchronous online. So even if, so just want to warn you, even if you get a notification saying we're on a 2-hour delay and classes in the morning are canceled, if that word is used, that doesn't apply to me. I just ignore that and I do the asynchronous thing. I'll have something for you. I'll email you. Check your email if classes are canceled because of snow. Usually, if the whole day is canceled, the language in the email will be check with your instructor about online work. But for whatever reason, I understand why, is that, I don't know, we don't have to go into it. I don't like it, but I just do it asynchronously, though. So even if classes are canceled, you'll have something that you get to do. Yes, Hayden?
Does this apply to the statistics class as well?
It sure does. I forgot to tell you, but yeah.
Just wanted to make sure.
Oh, absolutely. Yeah, I'll be, I mean, this is in that syllabus as well, but thank you. I'll remind everyone on Monday. Okay. What else do I have to do? Oh yeah, here, the bottom. Here, your favorite part. How am I going to earn my A? That's what you want to know. So the way you can earn your A is do well on your exams. Wait, this is the wrong one again. So do well on the exams. There are 3 exams scheduled. I might have a 4th exam. I don't know. It just depends on how things are going. There might be some sort of a glorified quiz that is sort of like an exam because the stuff after spring break is particularly grueling and nice to break it up a little bit more. But anyway, right now, tentatively, we have 3 exams scheduled for the 31st of this month, the 21st of next month, which is the day before spring break starts. So just be warned, don't schedule that flight too early on that day. And then the 28th of March. There are daily assignments, which I'll show you in a bit. Hopefully we'll get one for this weekend. And then there are daily quizzes and other activities that will go into your grade. And finally, a comprehensive final. And I see that does not add up to 100%. How did that happen? Yeah, I guess I edited, yes. I didn't edit the cardstock is wrong. You can just change is the date right? The date's right. Yeah, you can change comprehensive final to 30% from 20%. So my apologies for that. But I guess that I should mention, and I should have mentioned in statistics, is that these are subject to change. I will notify you if there's any changes to the syllabus. Mainly it would be like dates, things like the percentages. So anyway, there it is. So yeah, 30% there. And then you have the standard plus minus grade scale over there on the right that you can see. And that's it for that. There's still a few topics that I have to go over legally, but let me just stop here because I think this is probably what you care the most about. What sort of questions, concerns, fears, or worries do you have about anything that we've talked about, either on this card or on the screen? All right, well, let me go through the legal stuff that I have to do. Academic integrity, basically don't cheat. I have to go over this because, why is this like this? Okay. Because I understand that not all professors do, and I want you to be fully aware. If you cheat, I'll just do this quickly for those of you who heard this already in the first class. If you cheat the first time, I have to deal with it. Well, I have to deal with it on any time it cheats. So it's really uncomfortable. I have to call you into my office. I have to investigate. I have to talk to you. It's more obvious than you think when you cheat. It is, it's surprisingly obvious. And I think why? Why do you do this? I do my best to discourage cheating. Like on exams, I have 2 different versions of the exam that I pass around, and I'll let you know that there's an easy version and a hard version. But so anyway, don't cheat because I have to deal with it. Secondly, if you cheat, after I investigate and determine that you have cheated, actually even before, I have to contact academic affairs. That's the first step. And then I call you into my office. And they tell me if it was the first offense, second offense, or third offense. If it is the first offense, I get to determine what the penalty is, but the recommendation is a 0 for whatever it is you cheated on. So if it turns out that you did cheat, then you would get a 0 for the exam, whatever it is, which could be a big deal. I've had students go from A's to C's because they cheated on the final. If it is the second offense, then it's out of my hands. After I investigate and determine that, in fact, it was cheating and present my report, then academic affairs deals with it. And the penalty is generally, I think it's not generally, I think it's always, you get a 0 for the entire course. I've had that happen, I think, 2 times in my 28 years here, where I've been notified, well, this person's all done. And one time, the student said, well, I'm going to have to retake this anyway. I'm going to keep sitting in on the class. I was like, that really shows a lot of humility and really, I don't know, it was a pretty mature decision, I'd say. So I was impressed with that particular student. The other student just disappeared, and I don't know that I ever saw them again. Then if it's the third time that you cheat and it turns out that you actually did cheat, then academic affairs, once again, I don't deal with it. They do. They just boot you, kick you out, and you're no longer a student here, although you can appeal. There's some appeals process, but generally you have to sit out a semester, I think. I don't know. So it's a pain. Don't do it. Don't cheat. Okay, next, accessibility services. If you've been here, which most of you have for a little bit, you know what this is, but do avail yourself of accessibility services if you need them. And this could be as simple as just working with someone over in the Center for Student Success to understand that, I need to provide you with a less light, like closing the shades, or I don't know. There could be environmental issues, or it could be as drastic as needing to have tests elsewhere or other accommodations. So please do avail yourself of those. I'll mention just briefly the Title 6, 7, and 9 compliance. I'm always curious what happened to Title 8. But Titles 6, 7, and 9, apparently these are the titles, the law dating back to the 1970s, where by federal law, we cannot discriminate on the basis of race, color, sex, national origin, age, disability, military service. And so if there are issues regarding those things, please do use the reporting mechanisms that we have. We have an Office of Civil Rights that you can go to talk to someone, and you can use this reporting form if you feel like you've been discriminated against. One note, though, which is quite lengthy. By the way, all of this is boilerplate that I was given, all of these statements. So this should be in every one of your syllabi, is these things. Is this pretty long description of the fact that as far as Title IX goes, faculty and staff at MVNU are federally mandated to report anything that we hear. So if we hear of either like a sexual assault or I don't know, hazing or anything, there's a whole litany of things that and when in question, I'm just gonna report. And in some instances, it's required that I call 911 first, and then I talk to people on campus. So anyway, I just wanted you to be aware of that, not as a threat or anything, because I learned recently that some of my colleagues haven't always made this entirely clear at the front end. And so especially like if you can imagine an English professor reading essays, and in the essay is something that is reportable. Well, they have to report it by law. So just be aware. There are people and offices on campus that are not mandatory reporters. Those include the ones that you would expect, the spiritual life and the counseling center. There are a few faculty as well. I don't want to name names, but I know, because I don't know if these things change over time, but I know of at least two of my friends who in the past have been non-mandatory reporters and are able to. So these are people who generally are elders in the Church of the Nazarene or have been ordained in some way so that they don't fall under the umbrella of the federal law. So anyway, if you can seek those people out, I could even direct you to those, or at least I think I know who some of them are. So if you really need someone to talk to and you don't want to talk to me because I'm going to report whatever it is, then there it is. So that's what this is. So at the very end, and also in very, very small font on your page, I have the final exam schedule, or at least an abbreviated version. I only put what I thought was, most classes. There are a few classes that fall outside this scope, but I put this here because of, a number of years ago, I had a student come to me and say, I have a final that meets exactly the same time as your final. What should I do? And I pointed out that what he should do was to go to his other professor and say, you scheduled your final for the wrong time, because we have this to avoid that sort of thing. So you can find when our final is. It's on April 30th at 7:50, but you can also figure out when your other classes' finals are. Like I said, there are a few finals that I don't have on this, or wait, no, they're on this one. This is the full version. They're not on here. So, because who has classes that begin at 7:50 on Tuesday, Thursday? Oh, you do? Oh, you have a question? Yeah. So, yeah, there's that one there. So, yeah, these are very unusual times. So, but if you have them, there they are. I just didn't put it on your cardstock because I was trying to save room for other stuff. Whew. So subject to change, but this is pretty good. Okay. What sorts of questions, fears, or worries do you have for me? Yes, Hayden, thank you. I'm sorry?
What homework do we need to bring?
Good question. Well, we're going to find out here. I think we're going to be okay. Yeah. Yeah, good question. Let's find out. So, and I am curious to see, I've changed the format on Moodle a little bit. Here, I guess can I just log in as a student? Let me find out. Just a sec. If I can, then I don't have to ask you to do this. Switch role to, yeah, look at this. I can switch role to a student. I will be a student for just the moment. Okay, so this is what you'll see. Oh, interesting. I have done that. I didn't realize that you had these little check marks. Okay, well, homework. Oh, yeah, okay, this looks good. Okay, so on Monday, and I'll try to, I didn't put dates here because things tend to shift a bit. But you can see on the homework, you have these little check boxes. You can check them off. Look, oh, I'm 25. Well, that's going to, obviously, this list will get longer. But you could check them off, I guess, and then keep track of the ones you've done and the ones you haven't done. So I don't know if this is useful to you or not, but I thought I'd experiment with this particular way of putting information on Moodle. And if it's annoying to you, then I can always just go back to the static thing that doesn't have the checkboxes. Yes, for Monday, it's this first one, section 5.2, page, whatever page that is. And we're going to have time for that, hopefully, because we're going to be able to cover the material. Unlike in statistics, for those of you who were in statistics an hour ago. What other concerns or questions do you have about Moodle or anything like that? Or things that, yes, what's your name again?
America.
America, what's up?
What about like the people that don't have their
If you don't have your book. So this is something that I don't have here, but I told my statistics students that one of the primary ways you can guarantee doing well in this class is to make friends. So I know that you've already got a little cadre of friends back there, but make friends with other people. Now, so Americo, since you asked, do you know when your book will come?
I believe Monday.
Okay, so it's en route.
Right.
Okay, so it's en route. So I don't want to put anyone else on the spot, but how many other people have not got a textbook yet? Just out of curiosity. Oh, what? How in the world is this possible? Okay, well, okay, so if you haven't even ordered your book yet, you may want to opt for fast shipping. But you also, if you haven't ordered your book yet, you have that option of looking into the loose leaf version. So, yes.
I don't got that Prime delivery.
Yeah, well, thank you for bringing this up, Americo. Let me ponder this over the next. I'll let you know. Don't worry. There are options that I could employ. I mean, I could just put a scan of mine. Let's see. So, thank you. Or if you are lucky enough to sit next to one of the 20% of people here who have their book, yes, you could look on or borrow theirs, work together. That's another thing, by the way, is doing your homework with a friend. It's really helpful because sometimes you know how to do the work. Sometimes your friend does. And it's always good to be able to teach someone else. That's really how you learn something, is if you teach them how to do it, then you really learn the material. And anyone who's been involved in like SI or any tutoring situation, you know how it is. You can't go in there and not know what's going on. You have to know the stuff. So do make friends. Make friends with people who are smarter than you, who can teach you, but also make friends with people who need help so that you can teach them. It'll help you as well. Okay, yeah, let's see how far we get, Americo, and I'll modify as necessary, and I'll try to adjust. All right, any other concerns or questions before we get on with this? Yeah, what do you think, Abby?
Do you use perfect fit on exams and quizzes?
Yes. So, yeah, absolutely. I don't know what to say other than that. You'll find out. Yeah, for quizzes, I'm a little bit less because it's kind of a pain, but still, yeah. If you don't get there's one problem, you get the answer wrong, but you've shown me your work. Yeah, I generally give credit for that. Yep. Anything else? Other things? Yeah, some of these people have had me before, and they're like, "Yeah, he does." So you can ask your friends. So, All right, well, let's go ahead then and see how far we can get on this. So today and Monday are reviews of things that you had in Calc 1. However, these are things that you might not have covered in depth. Not only that, they're near the end of the course, and it's not that I don't have faith in my colleagues, but I know how it is. I've taught Calc 1 before myself, and it's difficult to pack it all in. And so today, what we're going to be covering is we're going to be talking about the definite integral, but not anything, not just any old thing about definite integrals. I want to talk about the actual definition of the definite integral. And it's not what you're thinking. You're thinking of the fundamental theorem of calculus, even though you might not think of it in that way. No, this is the definite integral. The definite integral the definition is the area under the curve, under a curve. So definite integral just means area under a curve. And I realized that we have this tool of the fundamental theorem of calculus that allows us to compute that area very quickly using antiderivatives. But I want to back up just a bit, and there's a reason for this, because a lot of what we do is we're going to be dealing with applications, and in order to understand those applications, it's going to be helpful to be reminded of this from time to time. And I'm going to pull out the fundamental theorem of calculus over and over again. It's my favorite theorem of all of calculus for sure. But we really need to understand this because it's the framework for many of the applications that we use. So that's why I'm going to go back here, and this is what your homework is on. So area. This is the sort of thing that we do with a definite integral. I'm sure you can come up with this. Ooh, you know what? Let's do this for fun. There we go. It's always fun for me to just put people on the spot. There we go. But Darren's used to it. He doesn't mind. Darren, do you know the area of this big blue block here?
49 units.
Yeah, say again. I'm sorry. I think I misheard.
Oh, it's 42.
Yeah, 42. Very good. No, it's early and it's the first class. That's good. So 6 units across and 7 units up. Yeah, you can compute the area. And so the definite integral of that function, that constant function, would be 42 because it's the area under the curve there. Okay, that's easy enough. But what if I did this to you? No, that doesn't make any sense, does it? Let's change this. Why did it do that? How about that? Okay, so I have this little pen here. Okay, what about this? So let's get this area here just for fun. Ben, I know you can figure out that area, can't you? The total area of the blue region?
Which bend?
Oh, there are two bends? Wait a minute. Okay, it's you, but I need to know how I'm gonna but you should be happy. You should have wanted this one. This one's the easy one. I'll figure out a way I might have to learn your last name and how to pronounce it properly. That'd be much more fun for me. But Ben Peoples. For now, I'll do Ben Peoples, and then I'll just be Ben H. Okay. We'll go with that for now. Ben Peoples, what do you think? What's the total area here?
30.
All right, so what did you do? You just added together the two rectangles. And some of you know where this is going, and you're not happy. Well, I'm not either. But yeah, this is going to be 21 plus 9, which is equal to 30. Okay, so that's nice. Well, what about this figure here? Find the area. Now, I know what you're thinking. You can do this using your antiderivatives. And we all have that tool in our tool chest now because we've all had Calc 1. So the way that you would do this, if you were allowed to, but I'm not going to, at least not for now, is you would do something like this. The definite integral from -3 to 3. And actually, by the way, this is all good. This is there. And you would actually compute this using the fundamental theorem of calculus, which says that when you want to compute an area like this, you can just use the antiderivative. But let's say we didn't know the fundamental theorem of calculus, which at one point in your life you didn't. Do you remember what your teacher made you do? How she made you suffer? What did you do? Yeah, rectangles, right? Yeah. Yeah. So you do the rectangle thing, and you approximate the area, and then if you were really cool, you would do a limit. and the limit as the size of the rectangle got smaller and smaller. That was the best. I remember being fascinated by this, but I'm not gonna make you do the limit. I just want to remind you of the idea of putting rectangles in here, because that is the thing that will be so helpful as we move forward and do some applications. It's surprising where this pops up. I remember talking with an engineering student a couple years ago, solving a problem for one of their classes. They came to me for help because I just happened to be in my office. And I was like, well, I don't really know engineering, but I can see what we can do. And so we were working through it, and then I was like, wait a minute, we can do this, and then we can apply the fundamental. It was so beautiful. I'd drawn little rectangles, and I applied the fundamental theorem of calculus. It just made me feel so good as a mathematician, because that's what mathematicians do. We come up with the formulas that help you guys, the engineers and the computer scientists and so forth. Okay, anyway, getting back to this. Yeah, the right way to do this. So we don't know the exact area. Let's do this, let's approximate it, and you can do this using rectangles, exactly what you suspect I would do. So let's actually do this using these rectangles. It's not as hard as it might look. By the way, that there are different ways to draw the rectangles. So let's just get this out of the way now. The way I've done it here is I have drawn these rectangles to be the maximum of, so each of those rectangles is the tallest point on each of those little intervals. So you break it down into little subintervals, and then you do the maximum. There are other ways you could do the minimum. You could do the left end point. Perhaps you remember this. In fact, on your homework, I believe it's more things like left end point. In fact, why don't we just shift and do left end point? Let's just get rid of those. Here, we'll do left end point or right end point. So let's approximate this using the left end points of each of these intervals. So there they are. So if we're using left end points, what that means is that the height of the rectangle will be, which that one's boring, will match the left end point. So the first one is boring. The second one is more interesting. And then the third one, and then the fourth one, and then this one, and then this one. Okay, good enough. So now all that's left is to figure out how tall these are, but I have this function here. That's easy enough. In fact, I'll bet you could figure this out. Let's see, this rectangle obviously is just 0. What about that rectangle? How tall is that rectangle? Let's see, who gets to do this? Ben H? No, I'm just kidding, Ben. It's not. I'm just randomizing using my little randomizer here. Caleb, this, by the way, helps me learn names. Caleb, do you know how tall this rectangle is? So you put the 2 in here, you get 4, right? And then subtract from 9. 5, you're in. Yeah, so basically, you want to know what this point is. The left end point of that rectangle would be -2. Plug it in here, and you get 5. Yes. So this is definitely not to scale, but it'll work for now. So basically, to get these, I'm going to plug 1 into that, -1 actually. 9 minus -1 squared gives me 8 for this rectangle. That rectangle, 9 minus 0 squared, which is 9. This rectangle, 9 minus 1 squared, which is 8. This rectangle is 9 minus 2 squared, 5. So I've got the heights of my rectangles. Now let's just add them up, right? 5 plus 5 plus 8 plus 8 plus 9, 16, 26, 35. Did I do that right? 35. There it is. And this is surprisingly close to the true answer. We're not going to be doing this necessarily. Okay, so this is, the idea is that we do this. We should do the fundamental theorem of calculus so that you see why I care. Well, I'll do pictures first, then we'll get to the fundamental theorem of calculus. So we have, this is called the right endpoint, the right sum. You would use the right side of each of these intervals. So notice that the rectangle, this one's a degenerate rectangle, it's just flat, no area. But this one matches on the right side. So these are right sums as opposed to the left sums. So here's the left sums. This is the one that we actually just did. So right sums and left sums. You could also use the midpoint. I don't have this drawn here, but a midpoint, you can imagine what it would look like. The rectangle would go up. Here, I'll do this. Maybe I'll just erase what I have back here. Just a minute. So a midpoint would look something like this. So this rectangle goes up and it matches the height at the midpoint. So each rectangle would match at the midpoint. That would be a little bit more of a pain to do, especially with this function, because you would have to compute 9 minus -1/2 squared. What's that going to be? That's going to be 8.75, I think. Yeah, so it's not as fun as nice integers. And by the way, I'm finding the areas of these rectangles, and it's just that I've picked a nice, easy gap here. If the rectangles were 2 units wide, then I would have to multiply the height by 2. So just to warn you, if you have to do that on your homework, which you will. But the point of this is that the fundamental theorem of calculus says that if we do this over and over again, that is, make the rectangles smaller and smaller, computing the area each time, the limit of that process, the limit, I'll write this down because this is what I'm going to be harping on quite a bit, the limit as the size of the interval. So delta x is the size of the rectangle. Delta x approaches 0 of this summation. And I'm being a little bit loose with my notation, but that's okay. I just want to make sure that we understand the general structure. So the limit of that is equal to this definite integral. From a to b I'll go with. Dx. And then I guess that's not the fundamental theorem of calculus. That's a different theorem. So this theorem just says that the limit of a Riemann sum is the area. But here's the fundamental theorem of calculus. And that is that this will equal f of b minus f of a, where capital F is equal to the antiderivative of little f, or a antiderivative. So I know that you're thinking, well, isn't this the same as this? It's not. This, when you put the numbers on it, that's a definite integral, and that means area. This, when you don't have the limits, this is called an antiderivative, which is the opposite of a derivative. So you use this. You know this. In fact, I will prove you know it because we are going to do this. You remember back here, where was my left sums? Left sums, we did this. We got the area. The area was 35, was it not? It was. So let's actually do this using what you learned at the end of calculus. And that was that you could just do an antiderivative, 9 minus x squared dx. And you did something probably like this. So we need an antiderivative first. So Ethan gets to show off what's the antiderivative of 9 minus x squared.
I will be honest, it's been like a year since I've done another math class.
Oh, okay, okay. Okay, so it's going to come back to you though. Once we get the rule, let me find someone to help you out. This is a great example of how Ethan is going to do a great job this semester because he's going to find someone and they're going to review together over the past year. Red, what is the antiderivative of 9 minus x squared? I know you know this. You use the power rule.
When you reverse it.
Yeah, it's the antiderivative power rule. Yeah, go ahead, Red. Oh, you're going to have to. Okay, you're going to help your friend. Your friend is going to help you. But yeah, this is the sort of thing that some of you are like, I got this right there. That's good. And the rest of you, and Red's going to work on this, it's going to become more. But Michael or Americo.
9x minus x cubed.
Yeah. Excellent. Yeah, 9x minus x. So now you remember that if you have a constant, the antiderivative is just that constant times x. And if you have a power, you use the power rule. And the power rule says add 1 to the power and divide by the power. It's like the opposite of a derivative. Now it's all coming back, isn't it? Isn't that great? We'll take our time with these. It's okay. This is why I do these reviews here at the beginning. I'm not going to drop you right in the middle of some nasty Taylor series. Yeah, okay. Well, let's go ahead and do this now that we've got that, and hopefully this is shaking some, like stuff loose, and you're like, oh yeah, I remember that notation. Well, let's see if we really remember the notation. Where are you, Landon? Where are you? There you are, Landon. Landon, what do I do with all of this now? Do you remember? That's right. So you do the top value minus the bottom value. In fact, that's what the fundamental theorem of calculus says. Where did it go? Where did I put it? There it is. It says take the top value, do the antiderivative, plug it in, subtract off the bottom value. That's fundamental theorem of calculus. The thing that I'm really interested in is this transition that allows us to apply the fundamental theorem of calculus. And so this sort of a diagram, we're going to be drawing lots of rectangles. I just want to warn you, so many rectangles. Every time you come up with a new application, I'm going to draw a picture, and we're going to put a little rectangle on it, and then we'll solve it. And the rectangle will guide us towards how you set up the problem. But let's finish this up. I'll do what Landon suggests. I'm going to plug in the upper limit. I get 9 times 3 minus 3 cubed over 3. So that's the upper limit. Sorry, it's going to go on a separate line. Minus 9 times negative 3 minus negative 27 over 3. Okay, I think I got this. There's going to be a bunch of double negatives I'm going to have to be very careful with. So you watch me. Make sure I don't mess up. So let's see. This first thing is going to be 27 minus 9. And then minus negative 27 plus 9. There, I think I got so far so good because you multiply those negative times a positive, and here it's negative 27 times a negative over 3. So I've got 18 plus 18 because of the double negative, and that equals 36. Look how close we were. Approximating with rectangles isn't as bad as one might think. We're within 1, which is, what's that, 3% off? It's a 3% error. That's not much at all. So, excellent. We're doing great. So, yeah, on your homework, so you might wonder, well, what in the world are we going to do for our homework? Well, our homework is going to be things like this. Take this function. So this function is y is equal to 3 times the square root of x. And I want you to approximate this area using midpoints. So I'll just demonstrate this really quick. Midpoints and 3 subintervals. So you may have done this back in Calc 1. Maybe not. This sometimes gets skipped over, but just a little practice. Okay, so if this was the task at hand, well, I've got this area. I'm going to divide it into 3 subintervals. Do you see my 3 subintervals? Beautiful, aren't they? And then I'm going to put my midpoint, so the height of the rectangle will match the midpoint of the subinterval. So there's the first one, here's the second one, and here's the third one. There we go. Lovely. So So anyway, now that we've got that squared away, now that I'm looking at this graph, I'm not so sure that that is the graph of 3 radical x. It might be 3 times the cube root of x, to be honest. But who cares? We're just going to ignore it if it doesn't line up perfectly. Now I'm going to figure out the heights of these rectangles. This one is easy. This is going to be 3 because when I plug 1 into that formula, I get 3. This one is going to be 3 radical 3. Radical 3 is 1.732. 3 times 1.732 is, I think, a little bigger than 4 1/4, isn't it? But whatever. We're going to leave it like that. And then this one will be 3 radical 5. Yes. whatever. Close enough. And then, of course, my final answer will be the size of the first rectangle, 2 times 3. So this is 2 times 3, which is 6. And then this one is 2 because these rectangles are all 2 units wide. So this will be 2 times 3 radical 3 and 2 times 3 radical 5. So what's this? 6 plus 6 radical 3 plus 6 radical 5. We could punch this into a calculator to get a better approximation or an approximation of this, but whatever. My main concern is that you are able to make the connection between the definite integral and this whole rectangle business. We're not going to be dwelling on this, but I just thought that this would be useful as we get started. One more, and then we'll be done for the day. And that's this beautiful kidney-shaped pool. And I want to know the area of this pool here. And we could do it a variety of different ways, but let's just suppose that the instructions said to do this using the right endpoints. So the right endpoints means that I'm going to draw rectangles, and those rectangles, let me change colors there so it shows up better. So the rectangles will match the right side of each of these little regions. So this one will be like this. So you can see what's happening, hopefully. I'll just do this here. In other words, this one is going to be 20 times 8. That one is 26 times 8 for area. And this one here, and so on. This one just to illustrate, because this is the right endpoint. So if it said right endpoints, this would be 8 times 35, because all of these are 8 units wide. At any rate, I would add up the final one, by the way. Last one is boring. It's 0, because this side is 0, so 0 times 8. And you might say, oh, you're losing all this area, but don't worry. It kind of gets, when you do this sort of procedure, usually you lose some area and you gain some area. It works out. So anyway, that's the way I would add that up. So you're going to have a couple of homework problems that ask you to do something akin to this. Okay, so I'm going to try to figure out how to deal with the homework. For now, go ahead and work on your book thing. I think what I'll do is I will just, even though it's it's gray area, but you're all getting the book eventually. I will do a scan of my book and put it online under the homework section temporarily, just the one homework, this 5.2, so that you can look at it. It's really not hard, and you can Google if you need help. But I think it's not going to be that difficult. All right, so there will be homework due Monday on paper.